Usually when you look at cloud architecture updates, it feels like, well, staring at a giant box of random disconnected Lego pieces.
Oh, absolutely. Yeah.
Right. There's a new database feature here, a random network tweak over there, and you're just left wondering how any of it actually fits together. But we have a stack of 46 different AWS announcements in front of us today.
It is quite the stack, yeah.
All of them released between April 6th and April 10th, 2026. And our mission today for you, our listener, is to cut right through that noise. We're not going to read you a dry laundry list.
Right, because nobody wants to sit through that.
Exactly. Instead, we're going to connect the dots, because when you step back and look at how these pieces interlock, they reveal 4 massive, fundamental shifts happening in the cloud right now.
And they really are fundamental.
We are talking about AI gaining true autonomy, the total collapse of traditional data storage silos, the scaling of compute from the absolute edge all the way out to quantum physics, and entirely new ways we have to monitor this sprawling complexity. It is just an incredibly exciting puzzle to solve.
It really is an architectural turning point. I mean, if you just scan the raw headlines of these 46 updates, it is incredibly easy to get overwhelmed.
For sure.
But none of these releases are random. They are puzzle pieces of a singular, highly evolving ecosystem. AWS is very deliberately laying down the tracks for a future where the cloud does not just host your applications, It actively participates in managing, defending, and optimizing them.
That brings us right to the first major shift, which we are calling the brain upgrades. We are starting with the brain of the cloud because AI is no longer just, sitting in a chat window generating text for us.
Right, it's doing way more now.
It is taking physical, autonomous action on your systems. The biggest headline here is the Amazon Bedrock AgentCore Browser. It now natively supports OS-level interactions.
Which is huge.
We are talking about an AI agent that can execute mouse clicks, use keyboard shortcuts, drag, scroll, and even take full desktop screenshots. Okay, let's unpack this. It is like we have moved from asking a librarian to fetch a book to the librarian actually reading the book, writing a thesis, and reorganizing the entire library's shelves for you.
That is a great way to put it, yeah.
But wait, I have to push back here. Isn't it absolutely terrifying to give an AI direct OS-level control over your mouse and keyboard? Like, how do we stop it from, say, deleting the wrong production database file or sending a confidential email by accident?
What's fascinating here is that AWS entirely anticipated that exact fear. They didn't just release these autonomous capabilities into the wild without a highly secure leash.
Okay, that is a relief.
Yeah, you have to look at the AgentCore OS abilities directly alongside another major release from this week, which is the Amazon Bedrock Agent Registry. It acts as a private, heavily governed catalog for all your AI agents, servers, and tools. So before that AI librarian can start reorganizing your digital shelves, it has to go through strict programmatic approval workflows.
I see. So it's not just running wild.
Exactly. Administrators use the registry to enforce rigorous governance policies, defining exactly what an agent is and is not allowed to touch. And furthermore, AWS CloudTrail is integrated into the registry to provide complete, immutable audit trails of every single registry access and administrative action.
Oh, wow. So you have complete oversight.
You do, complete oversight.
So it operates as an autonomous system, but strictly within a highly visible, tightly controlled corporate structure.
And this ties into a much broader trend we are seeing across the entire stack. AI is moving from being a reactive tool to a proactive defender and operator. Take the new Claude Mythos preview available on Amazon Bedrock.
I saw that. That's Anthropic's new one, right?
Yes. And this is not a standard chatbot. It is a fundamentally new model class from Anthropic focused purely on cybersecurity. It comprehends massive, complex code bases and autonomously identifies sophisticated software vulnerabilities before bad actors can even exploit them.
That is incredible. And we are also seeing this proactive AI in IT operations, right?
Yeah.
Like Amazon Workspace's advisor was just released to provide AI-powered troubleshooting for virtual desktop.
Yeah, it analyzes system configurations and recommends fixes automatically.
It is even stepping into our FinOps, which I find wild. I noticed AWS Cost Explorer just added natural language query capabilities powered by Amazon Q.
Oh, that's a massive time saver.
Right. So instead of a financial analyst manually building complex pivot tables to figure out why a cloud bill spiked, you could just type, "Show me my top spending services for this month," and Amazon Q dynamically builds the charts and provides the analysis.
It is brilliant.
To back that up, Amazon Bedrock itself now supports cost allocation by IAM user and role. You can actually tag your model inference costs to specific teams or projects. It makes it incredibly easy to see which department is braining through your AI budget.
And, to do all this efficiently, those AI models require massive coordination on the back end. This week, Amazon's SageMaker HyperPod introduced gang scheduling for distributed training workloads.
Gang scheduling, let me make sure I understand that.
Let me explain why that matters. When you are training massive AI models, you need multiple compute pods working simultaneously. If some pods start while others are delayed in a queue...
Oh, the active ones just sit there waiting?
Exactly. They sit idle, leading to deadlocks and incredibly expensive wasted compute. Gang scheduling ensures all required pods are ready and provisioned before the training job even begins.
That makes so much sense.
Coupled with the new updates to Amazon's SageMaker Unified Studio, which just added notebook import and export features to easily share data science environments, along with new serverless workflows and identity center domains, AWS is ensuring the brain has the sophisticated tooling it needs to operate at a massive scale.
Which transitions us perfectly to our second massive shift.
Yeah.
Because for this autonomous, highly complex AI brain to actually work, it needs data.
So much data.
And not just a little data, yeah. It needs instant, frictionless access to oceans of information. That leads us to the new data foundation, where AWS is essentially smashing storage silos. The absolute marquee announcement here is Amazon S3 files.
Oh, this one is huge.
Right. For years, we've had object storage like S3, which is essentially a giant warehouse of unorganized boxes.
Yeah.
Great for holding infinite stuff cheaply, but really hard to browse. And then we've had file storage, which is like a perfectly alphabetized filing cabinet. S3 files is like magic. It turns the boxes into filing cabinets instantly. It allows S3 buckets to be natively accessible as high-performance file systems using EFS technology, but without any data duplication.
Which is the key part.
But here is my question. Why is this such a big deal for machine learning teams specifically? Like, why couldn't he just copy the data over from S3 to a file system like we have always done in the past?
It really comes down to the massive friction, time, and cost of data duplication. I mean, when you are training a model on petabytes of unstructured data, copying that data from an object store into a file system can take days.
Oh, wow. Days just to copy.
Yeah, and it literally doubles your storage costs while you do it. By allowing file-based applications and AI agents to read directly from S3 at multiple terabytes per second, S3 files completely eliminates those data silos. Your AI agents can now persist memory and share state across pipelines natively without moving a single byte of data.
That is just so clean.
And this theme of frictionless access is everywhere this week. Consider the database side. Amazon RDS Blue-Green deployments just added support for RDS Proxy.
I'm going to make sure I have this straight. Blue-green deployments are how you safely upgrade a database. You keep your live blue environment running, you build a new updated green one, and then you switch the traffic over.
That is the concept, yeah. But historically, that switchover relied on DNS propagation. Waiting for DNS records to update across the internet can take unpredictable amounts of time.
Right, which causes application timeouts for users.
Exactly. By integrating RDS Proxy, the proxy actively monitors the database instances and instantly redirects connections to the green environment the millisecond it becomes the production standard. It completely eliminates DNS propagation delays. Access to your data remains continuous.
That is an incredibly elegant solution for maintaining uptime. We're also seeing a massive push to keep all this data physically closer to the end user and fully compliant. Oracle Database at AWS, which physically places Oracle Exadata hardware directly inside AWS data centers.
Which is wild to think about.
Yeah, to eliminate latency for legacy enterprise apps. It just expanded to 12 new regions, including the EU and APAC. And Amazon RDS for Oracle now supports the new custom Intel Xeon 6-powered M8i and R8i instances. Plus, they added support for OMA 24.1.0.0.0.v1, which ensures the Oracle Management Agent integrates flawlessly with modern cloud monitoring.
The fleet management updates are just as aggressive. AWS is ensuring massive database fleets stay secure without breaking functionality.
Right, like the Aurora updates.
Yeah, Amazon Aurora PostgreSQL rolled out specific minor version updates across the board versions 17.9, 16.13, 15.17, and 14.22. Simultaneously, Amazon RDS SQL Server rolled out the latest cumulative updates and general distribution releases.
So a lot of patching.
Yeah, these aren't just arbitrary version numbers. These are critical security patches applied systematically to protect data. Even Amazon Timestream for InfluxDB added customer-defined maintenance windows so administrators can control exactly when these patches are applied.
I want to challenge you on something, though. If S3 files just turned object storage into a magical high-speed file system, Why is AWS simultaneously expanding traditional file storage?
That is a very fair question.
Like Amazon FSx for NetApp ONTAP app just pushed its second-generation systems into 4 new regions, including GovCloud, and FSx for OpenZFS just landed in Melbourne. Plus, AWS Backup extended cross-region and cross-account copy support for FSx backups to 14 regions. Why are government agencies and enterprises paying for legacy file systems when cloud-native object storage is so much cheaper?
You are hitting on the core issue of legacy lock-in and enterprise architecture. Many government agencies and large financial institutions run applications that were written decades ago.
True.
Those applications have millions of lines of code specifically reliant on NetApp or OpenZFS storage protocols. You cannot simply rewrite those monolithic applications to use S3, even with S3 files, without risking catastrophic failure.
So it's a migration stepping stone.
Exactly. Expanding FSS into GovCloud allows those highly regulated entities to migrate to the cloud without rewriting their core applications. And to protect all this data, AWS is hardening the foundation. S3 Lifecycle now intelligently pauses expiration actions on objects if they fail cross-region replication.
Oh, so it won't just delete your only copy.
Right. It prevents a scenario where a local file expires and deletes itself before it has safely arrived at its backup destination. Furthermore, S3 rolled out a new default security setting that automatically disables server-side encryption with customer-provided keys on new buckets. It enforces stronger, automated key management best practices.
Which brings us to shift number 3, the engine room. Because to process this new, seamless sea of data and to power those autonomous AI agents we talked about, you need serious horsepower.
You really do.
And this week, AWS expanded the compute layer in every conceivable direction, from the traditional cloud out to the edge, all the way to quantum physics. So what does this all mean? Let's start with traditional compute. Amazon EKS-managed node groups now support EC2 auto-scaling warm pools. To me, it is like keeping a fleet of taxis with the engines already running, instead of building a new car every time someone hails a ride.
That is a perfect analogy for node provisioning latency. Instead of waiting for a cold instance to boot up an operating system, run initialization scripts, and install software dependencies during a sudden traffic spike.
Which takes forever.
Right. EKS can instantly grab a pre-initialized instance from the warm pool. It drastically reduces the time it takes to scale out your Kubernetes clusters. We see a very similar philosophy applied to serverless architectures this week. AWS Lambda response streaming is now globally available in all commercial regions.
Wait, how does streaming fit into the compute layer?
It serves the same goal as your waiting taxis, eliminating waiting. With response streaming, a Lambda function can send partial responses back to the client incrementally as the compute happens.
Oh, rather than buffering the entire payload.
Exactly. Rather than buffering the entire payload, which can be up to 200 megabytes before sending it. This significantly lowers the time to first byte. For latency-sensitive workloads, especially generative AI applications where you want to stream text tokens to the user the moment they are generated, this completely changes the user experience.
We are also seeing massive upgrades on the heavy-duty end of the spectrum, too. Amazon EC2 released the X8i instances. These are absolute monsters.
They really are.
Powered by custom Intel Xeon 6 processors with up to 1.5 times more memory, capping out at 6 terabytes of RAM. They are specifically designed for massive in-memory databases like SAP HANA. Then, on the complete opposite end of the spectrum, the physical edge. AWS IoT Greengrass launched new component SDK for C, C++ Open, and Rust with a tiny memory footprint of just 0.5 megabytes.
Half a megabyte, that's tiny.
Right. You can now run complex edge compute on incredibly constrained microcontrollers. And to track all this, EC2 Capacity Manager now supports tag-based dimensions and an account name dimension, so you can track your compute footprint by specific team or cost center. Oh, and Amazon Lightsail expanded to Malaysia to simplify compute for smaller workloads in Southeast Asia. But I really want to pivot to the bleeding edge here. Quantum.
Yes. The Amazon Bracket update is a significant milestone.
Bracket just added Rigetti's 108-qubit Cepheus quantum processing unit. The release specifically called out that Rigetti changed their architecture to use something called CZ gates. In plain English, why does a gate change matter for a 108-qubit quantum computer?
In quantum computing, your biggest enemy is environmental noise.
Like literal sound noise.
No, like temperature. Even the slightest temperature fluctuation or electromagnetic interference causes phase errors, and those destroy the delicate quantum state of your qubits. A quantum gate is essentially the logical operation you perform on the qubits. So Rigetti's shift to these adiabatic CZ or controlled phase gates, it is crucial because they provide significantly higher resilience to those phase errors.
So it's essentially like heavy-duty shock absorbers or noise-canceling headphones for the quantum computer.
That is exactly what it is. By acting as a shock absorber against environmental noise, researchers can string together far more operations before the quantum system decoheres and falls apart. This means they can run deeper, much more complex circuits for actual practical applications like chemical simulation and quantum machine learning. It is a major step toward making 100-plus qubit systems commercially viable.
Incredible. Okay, we have our autonomous AI brain, our smashed data silos, and our scaling compute engine from 6 terabyte EC2 instances to 108 qubit quantum shock absorbers.
Yeah.
But if we do not have a robust nervous system to monitor, network, and secure all of this, the whole thing falls apart.
It absolutely does.
That is our fourth and final shift. And here's where it gets really interesting. Looking at these updates, I noticed a very clear pattern. CloudWatch pipelines added a keep original toggle for compliance logs, alongside new conditional processing and drop event rules. Amazon Verified Permissions added human-readable aliases so administrators don't have to memorize random system IDs.
Right, which is a huge pain.
Exactly. And the new Smithy Java client framework reached general availability, automatically generating type-safe Java clients for developers so they don't have to write thousands of lines of boilerplate code from scratch. It feels like AWS is acknowledging that as the cloud gets infinitely more complex, human cognitive load is the biggest bottleneck. Am I reading too much into this?
If we connect this to the bigger picture, you are entirely correct. The tools in this nervous system layer are explicitly designed to reduce human error and cognitive fatigue. Just look at the major update to Amazon OpenSearch service. They introduced native integration with Amazon Managed Service for Prometheus, along with comprehensive AI agent tracing.
Okay, how does that help with fatigue?
Well, previously, site reliability engineers had to constantly context switch during an outage. They used one premium tool for metrics, a completely different one for logs, and another one for traces.
Wait, which sounds exactly like the data silo problem S3 files solved for machine learning.
It is the exact same philosophy. OpenSearch service unifying all of this into a single interface means you stop duplicating observability data and stop context switching. You can query Prometheus metrics directly alongside your application traces in the OpenSearch UI, and they engineered it to be substantially cheaper to run.
Oh.
Yeah, OpenSearch Serverless now supports Z-standard compression, which reduces massive index sizes by up to 32%. Furthermore, the managed service added Graviton 4-powered IH instances that deliver up to 60% better compute performance for storage-heavy workloads.
That 32% reduction means terabytes of log data just got significantly cheaper to retain. And it is not just observability. The networking updates share that same reduce friction, increase stability ethos.
Definitely.
For example, AWS RTB Fabric introduced health checks. Real-time bidding for ad tech happens in milliseconds. If an ad server fails, you lose money instantly. RTB Fabric now automatically routes traffic away from failed instances. Amazon IVS real-time streaming added redundant ingest, meaning if one video encoder fails, your live stream seamlessly falls back without dropping the broadcast.
Which is critical for live events.
Right. And AWS Transfer Family finally added IPv6 support for SFTP and AS2 connectors. That might sound incredibly niche, but AS2 connectors are the invisible glue keeping legacy BTB supply chains and EDI transfers running globally as networks slowly run out of IPv4 addresses.
We also see network simplification with Amazon Workspace's Personal, which solved a major headache by providing unique, publicly resolvable DNS names for private link VPC endpoints.
That is super helpful.
It really is. It eliminates complex DNS collision issues when managing virtual desktops across multi-account environments. And Route 53 Resolver endpoints now support DNS delegation in GovCloud, streamlining hybrid cloud connections between on-premises government data centers and AWS.
Security and FinOps got the exact same automation treatment. Beyond the verified permissions aliases we talked about, AWS Certificate Manager introduced a native search bar to instantly find expiring certificates by domain name or ARN. AWS Private Certificate Authority now supports customer-managed permissions via AWS Resource Access Manager.
Right, so instead of relying on broad, risky managed policies, you can precisely share specific read or write API operations across your organization.
Even FinOps and procurement are being streamlined. AWS Marketplace launched the Discovery API, allowing companies to programmatically pull software pricing and product details directly into their own internal procurement tools.
rather than manually browsing the console, yeah.
Exactly. And AWS billing and cost management dashboards now support scheduled email delivery. Executives get their PDF cost reports automatically delivered to their inbox.
Every single layer of the stack, from the way we query costs to the way we issue certificates, is being optimized to remove human bottlenecks.
Let's take a breath. We have covered a staggering amount of ground today. We started with the brain, Amazon Bedrock AgentCore, taking physical control of our operating systems, monitored by the rigorous new agent registry, while Claude Mythos proactively hunts software vulnerabilities.
Yep.
Then we moved to the data foundation, where S3 files perform magic, turning object storage into high-speed file systems to feed those AI models without copying a single byte. We explored the engine room, moving from EKS swarm pools acting like waiting taxis to Lambda streaming rapid responses, all the way to a Getty's 108-qubit quantum processor with its new stable CZ gates.
It is quite a journey.
Finally, we tied it all together with the nervous system, unifying our observability and OpenSearch and fortifying our networks so humans do not get crushed by the sheer complexity of it all.
It is a remarkable technological evolution, and I want to leave you with a thought to mull over. Think about the long-term trajectory here. With Bedrock agents now executing OS-level commands, Claude Mythos proactively finding vulnerabilities in code bases before they are exploited, Amazon Q directly integrating into our cost and usage data, and OpenSearch unifying all system telemetry. How long until we see AI agents autonomously deploying, patching, optimizing, and restructuring our entire AWS environments in real time? We aren't just looking at a set of new features. We are laying the groundwork for a cloud that architects itself.
A cloud that architects itself. That is equal parts thrilling and humbling, but clearly the foundation is being built right in front of us. Thank you for joining us on this deep dive. Keep exploring the pieces of this puzzle, keep asking the hard questions about the technology you rely on, and we will catch you on the next one. Remember, the pieces only make sense when you start connecting them.